Okay, hi, this is our last of the 3 quiz 6 problems I'm doing for you. Problem 4, it's last, but I think it's the easiest of the 3, just because we are back into the discrete world. Discrete random variables, I think, are much easier to work with sometimes than continuous, because you can actually see what's happening and put your hands on it. You're not talking about these regions of interest where you don't have a feeling in what this function looks like. Here's a problem. Let's say you were an academic advisor and you have 50 students you're advising. In a given quarter, X is going to be the number of science classes one of your students takes, and Y is the number of math classes. I've never been an advisor just because I don't know the rules at Rose good enough. I'll admit it. There's so many rules, double, major, minor, this, that. Anyway, so the advisor is just, suggesting to students what they should take. So let's suppose we randomly take we randomly out of a bag or pick one of the advisor's students. What's the probability that that randomly selected student is taking 2 math classes? So Y is the number of math classes, and so here's Y equals 2 right here, and we can see 9 out of the 50 students would be taking 2 math classes. So this is actually just 9 out of 50. I don't care, you don't have to reduce if you can. There it is. You can kind of see I have the marginal for Y down here and the marginal for X over here, right? So Y equals 2, you could actually think of it, it sums across all the X's. That's why when we find Y equals 2, we sum across X's, because they could be taking 2 math classes, no science, 2 math classes, 1 science, 2 math classes, 2 sciences. So 2 over every case of X, that's how I get Y equals 2. So there's the marginal down there, 9 out of 50, 16 out of 50, and 25 out of 50, so there we go. What's the probability we randomly select a student of this advisor and they have 2 math and 1 science? So Y is, right, so Y is math, so 2 math and 1 science, X equals 1 science. So here's 3, it looks like 3 out of 50. So I'm actually finding it, in case you want to know, I'm really doing P of XY, so P of X was number of science, so 1, 2. I mean, you're finding P of 1, 2. It's the joint mass function of X and Y. So that's what I'm doing, looking over there. What's the probability that we randomly select a student and they are taking more math than science? So more math would mean Y is bigger than X, right? So here, Y is bigger than X. So here, Y is bigger than X. Not there. Why am I having, it looks like it's just these 3, right? Where Y is bigger than X, because they're the same. So these 3 cases, so this would be 13 out of 50, right? I hope I'm not missing anybody. 1, equal, okay, yeah. So those are the 3 cases, so 13 out of 50. Last is I asked you to find the marginal for X, so I'm just asking you to find P of X. I asked this before, and people were trying to come up with a really nice formula. This guy is only defined for 3 X's, so you might as well just make a piecewise. So P of X is equal to, X could either be 0, or X could be 1, or X could be 2. Probability X is 0 is 21 out of 50. Probability X is 1 looks like 22 out of 50. And X is 2 is 7 out of 50. This guy's valid, adds up to 1. We could find expected value now. Same way for P of Y. So, sometimes you can find a really slick, nice function in terms of X or Y, but this is fine. You only have 3 pieces. A piecewise is, I didn't expect anything. I wasn't trying to make up a function that you could just stick X nicely into. So piecewise are fine for these. So I think compared to the other 2 problems, this is pretty nice, because this is just a nice discrete count up, look at all your cases. And for every X and Y, you actually get a probability value that makes sense. So anyway, there's our last one for today. And let me know if you have any questions or you want to see another one of discrete or continuous.